Alright, so now we have to find out the mutual inductance of two long coaxial solenoids. So for that we need to draw the solenoids first. So let's make the first solenoid. So that's the first one, the inner one, having a radius of small r. So we're going to say this as solenoid S1. Similarly, we are going to have another solenoid of a bigger radius and we are going to name it as S2. So both these two long coaxial solenoids are each of length L. So let N1 be the number of turns per unit length of the inner solenoid S1 of radius R1. Similarly, N2 is the number of turns per unit length of the solenoid S2 of the radius R2. Imagine a time varying current I2 through S2. So we are saying that I2 is the current flowing inside it. So it is setting up a magnetic flux phi1 through S1. Therefore, phi1 can be said as M12 into I2. So let's name this as equation 1, where M12 is the coefficient of mutual induction of solenoid 1 with respect to 2. The magnetic flux due to the current I2 in S2 is given by B2, which is equal to mu naught into N2 into I2. So the flux through S1, that is phi 1, is given by B2 into A1 into N1. Putting in the values, B2 mu naught N2 I2, putting in the value of A, that is pi R1 square into N1. N1 can be written as N1 into L. So combining the values, mu naught N1 N2 pi R1 square N1 I've already written, and L into I2. So it is phi 1. So let's just name it as 2. Now comparing equation 1 and 2, we are going to get the value of M12, which is equal to mu naught N1 N2 pi R1 square into L. So let us just name it as 3. Alright, so now let us just consider the reverse case. A time varying current I1 passed through the solenoid S1 results in the development of magnetic flux phi 2 through the solenoid S2. Therefore, we can say that phi 2 is equal to M21 into I1, where M21 is the coefficient of mutual induction of the solenoid S2 with respect to S1. The magnetic flux due to S1 is confined solely inside S1 as the solenoids are assumed to be very long. There is no magnetic flux outside S1 due to the current in S1. Therefore, the magnetic flux linked with S2 is given by phi 2, which is equal to B1 into A1 and not A2, and then N2. Putting in the values, mu naught N1 I1 into pi R1 square into N2 into L. Combining the values, mu naught N1 into pi R1 square into L, and then I1. Let's just name it as 4, name it as 5. So comparing the values of phi 2 in the equation 4 and 5, we come to the conclusion that M21 is also equal to mu naught N1 N2 pi R1 square L, which if we see was also the value of M12. So that is the value of mutual induction of two long coaxial solenoids. Also, we can write this M as equal to mu naught N by L, because small n was the number of turns per unit length. Similarly, N2, that is number of turns per unit length, pi R1 square into L. 1 L is going to get cancelled. So our value could be mu naught N. This was N1, this was N2. So N1, N2 pi R1 square by L. We can also write pi R1 square is A. So M is equal to mu naught N1 N2 A by L. So that's the value of mutual induction of two long coaxial solenoids. Thank you so much for your time. Have a great day. Bye bye.